Okay, for today's lesson, we're going to be talking about Lewis structures. So we have two main rules that we need to make sure that we follow with Lewis structures. Okay, all atoms that are involved need to have their outer shell full of electrons. Okay, remember hydrogen only needs 2. Every other one needs to follow the octet rule of having 8. And also all valence electrons that are available must be used in the situation. So we have phosphorus trichloride here, okay? And so where do I find the valence electrons? Well, if you guys remember off of our periodic tables, group 1 have 1, group 2 have 2. The transition metals don't really follow that, so we pick up the pattern again. Group 13 have 3, 14 have 4, group 15 has 5, group 16 have 6, and group 17 have 7. Okay, so those are their number of valence electrons. So phosphorus is in group 15, so it has 5 valence electrons that it can donate to this. Chlorine has 7, but I have 3 of those. Okay, so it's going to be 21 plus the 5 here, so it's going to be a total of 26 available valence electrons. Okay, so with this, you need to pick a central atom to build all of those bonds off of. And more often than not, the first element is going to be your central element. Okay, so we're going to pick phosphorus. We're going to have phosphorus, and we're going to have chlorine on 3 different sides. Okay, it doesn't really matter if you put this here. It's the same compound. Remember, these are 3-dimensional, but we're just doing a 2-dimensional picture of them. Okay, so now I'm going to just start placing the rest of these electrons to satisfy that first rule that all of the atoms must have their outer shells full. So chlorine and phosphorus both need 8. Okay, if I take a look at this atom has 8, this atom has 8, and this chlorine atom has 8. This phosphorus only has 6, so I'm going to need to put a 2 right there. Now we're going to just double check. These are the things that we're going to double check when we're done, that there are 26 available electrons. So each line represents 2 electrons. If I have a double bond, that's going to be 4 electrons. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. That is the correct Lewis structure for this molecule of phosphorus trichloride. Okay, we're going to jump here to carbon dioxide. We're going to see that this is a little bit different. Okay, so just like we did before, we need to check the number of valence electrons. So carbon has 4, oxygen has 6 times 2, total of 12. We got 16 total electrons. Okay, carbon is going to be my central atom. I'm always going to start with single bonds. If I take a look at this, there's no way I'm going to be able to just put dots everywhere, okay, to represent the full 16. So with carbon dioxide, we need to have double bonds. Okay, so each of those lines represents 2 electrons. So carbon has 8 satisfied. So that's 2, 4, 6, 8. Okay, and so each of these oxygens, they need 8 themselves. So we need to put 4 more around the outside for them to be happy. And we're going to double check that we have 16. 2, 4, 6, 8, 10, 12, 14, 16. This is what carbon dioxide would look like. Okay, so these are double bonds between these carbon and oxygens to satisfy both of these rules. So that's when we would need a double bond. We come over here, dinitrogen tetrahydride. Okay, so I'm gonna again do the same thing, figure out how many valence electrons are available. Okay, nitrogen, if I check my chart, it has 5, but I have 2 of those. So it's a total of 10. Hydrogen, that's 1, they're in group 1 over here. So that's gonna be a total of 4 more. So we're gonna have 14 total electrons that are available. Now this is a bigger molecule, so I have to kind of sort this out. So I'm gonna go nitrogen bonded with nitrogen here, okay? And then we're going to put the hydrogens on either side of this, okay, that are bonded to the nitrogens. So we got hydrogen here, hydrogen here, hydrogen here, and a hydrogen atom here. Okay, if you take a look at the 2 nitrogens that are on the inside here, okay, 2, 4, 6. They only have 6. This one, 2, 4, 6. It only has 6. Okay, so they need 2 more. Okay, so I'm just going to put the dots above, and now we're going to check to make sure that we have 14 electrons total. 2, 4, 6, 8, 10, 12, 14. So this is what dinitrogen tetrahydride would look like. Okay. Now down here we got some special ones. These are a little bit different. So this is a hydrocarbon. Okay. And so that'd be tetracarbon decahydride. Holy cow. So we got lots of molecules here. So with these hydrocarbons, these are very large molecules. So the trick to these is just build them left to right how they are written, okay? But we do need to check the valence electrons to start with, just like always. So carbon has 4, so 4 times 4, okay, is 16, okay? Hydrogen, that's gonna donate 1 per, so that's 10. So we're gonna get a total of 26 electrons, okay, that are available. Okay, so I'm just gonna build this left to right as it is drawn. So I'm gonna go carbon, and I'm gonna just connect all of those carbons, okay? And now I'm gonna place 10 hydrogens around that, okay? Hydrogen, hydrogen, hydrogen up here, hydrogen up here, hydrogen up here. One above, one below again. One above, one off to the side, and one to the bottom. Now, if you remember, hydrogen only needs 2 valence electrons. So each of these lines, hydrogen is good to go, okay? Now, all of the carbons, the way that we have drawn this, they are satisfied. They each have 8, but we're gonna double check that we have 26 electrons, okay? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Tetracarbon, decahydride, that's what that would look like. Okay, so again, if you notice, I'm going back through and I'm checking each to make sure I have all of the valence electrons accounted for and making sure that each of the atoms that are there have their outer shell full. Okay, this last one is special. It has a negative charge. So as we learned in our last unit, that means that it has 2 extra electrons. We're going to see that a lot of these compounds, when they that have charges like this, they need those extra electrons, or some need to get taken away so that to satisfy these rules, okay? So we're gonna start out just like we did, okay? So I have carbon, 4, oxygens is 6, but I have 3 of those, so that's gonna be 18. And then this, because there's extras, we're gonna be adding those 2. So we got 24 total electrons that I must place, okay? So my central element is going to be carbon again. I'm going to have carbon. I'm going to kind of squeeze it over here. Hopefully it's in the frame. Okay. We're going to have oxygens on the sides. Okay. Carbon's not good, is it? Okay. So we're going to try, okay, to put the oxygens first. So I've got a lot of electrons. So kind of the trick on this one, if I've got a lot of electrons, I'm just going to start putting dots in. We're going to kind of adjust from there if we need to. Okay, so I'm going to set them out. Okay, if I do this, okay, if you look, this carbon is good, all of these oxygens are good, but we need to double check that we've only used 24. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Uh-oh, I only have 24 available. So what do I need to do? I need to take, okay, I'll just pick this atom here. I'm going to take those 2 away, and I need to make a double bond, okay? And so that's the way that this would work. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now, the last trick on these, because this has a -2 charge, you need to put this into brackets, and then you have to put the -2 with it, okay? And so that's the last little trick on those. That signifies that this is an ion. It has a charge. It has extra electrons, okay? And so by the brackets, that's what that would show. So in the course of all of our videos, I hope that you guys are pausing, okay, trying them out on your own. Okay, I'd encourage you guys to do that. Go back, rewind, try it out again if I went too fast. Yeah, we'll see you in chem.